Well, yeah. Hey, Alice. This is the Ask Me Anything session for zero knowledge voting protocol implementation thing. And yeah, well, that's the what we're going to see is the presentation of one of the submissions. So like, here we go. Not so many folks, but anyway, I guess all the crucial participants are here. I don't know. Let's start with maybe a little bit of demonstration. Elias, would you like to?
Hello, everyone. Mikhail, can you give me?
Oh, yeah, sure. Just for the record, what we're going to see right now is the voting protocol implementation based on top of vote saver protocol, done with some specifics to, I don't know, let's say adjusted to be executed with Freetown thing, or whatever it's being called right now. All right, I still call it Freetown. Sorry, fellas. And well, yeah,
I can start.
Yeah, just go ahead.
So we watch execution of the protocol, which consists of several parts, several phases. These phases were described in README in the repository. So the first phase is initiation, where administrators prepare and trusted setup with the Gasnar keys and Elgamal encryption scheme keys. Next phase is casting votes, where voters send their encrypted and proved ballots to the FLD cluster. At this phase, needed checks executed, gross verification check, and final phase is tallying results, where administrator aggregates sended ballots, decipher them, and generates decryption proof and uploads this data to the cluster, which voters could download and verify. So let's watch the example. We watch example where 4 voters and 1 administrators. So at this phase, I initialize some scripts which simplify protocol execution.
We have 4 voters in here, as far as I see, right?
Yes, 4 voters and 1 administrator.
All right.
So we model participant interactions on one machine, but every command executed by every participant will be executed from a separate folder. For administrator, it's admin folder, and for voters, it's folders from voter 0 to voter 3. So, and to begin protocol, we firstly compile LSCS, I mean contracts.
Yeah, whatever they call it.
For this, we run this script.
Yeah, auto completion doesn't work in here.
Sorry. Problem here. I try to run from. So admin contract compiled.
Yeah, just for the record, the compiler which is being used is our fork of this whole thing, which supports the encrypted GRAS16 processing instruction.
Yeah. The next step is to generate addresses for participant. Addresses will be put to again other output folder, and keys will be put to keys folder.
Can we somehow increase the amount of voters? I don't know, like just changing the amount, I don't know, to the million. Well, not right now, but just theoretically, in case anyone wants to.
So addresses are generated, and the next step is to deploy contracts. To process this phase, we will special scripts will be used, and commands will be manually copied into terminal. So at this phase, we initiate voters, each one after another. At this phase, they generate their public and secret keys, which are used to generate proofs, which specified by the protocol description as PK ID and SK ID. Firstly, we should generate these keys in every folder of every voter. And we do this by using CLI. So 2 files were generated and keys were marshaled into these files. So we could run the script again and script using these files generate commands to send to the FLD cluster to deploy participant contract. But before this step, we should give some money to addresses of these voters to be able to proceed. So we use scripts from Castler Uninode scripts and call giver function. This is admin address. I make sure that addresses are correct. C1. There were previous addresses which was used in tests, so I restart script to get actual addresses. Make sure again that addresses are correct.
That's the one.
So accounts were some balance were given to the accounts. So let's get to the next step. It's at this step we deploy voters we call constructor of the smart contract and pass voters public key, which was generated earlier. Uninode script. All calls to FLD class will be processed from the folder where smart contract source code are placed, because keys are here. And also the second argument in the constructor is the admin address, in which context voting is processed. And for other voters, we go to their folders. Create keys. Files were created. Run again. Go to the TVM console, from which all requests are sent. So all voters contracts are deployed, and the next step is to deploy administrator contract. To do this, we firstly we deployed administrator constructor pass no arguments. For the next step, we model administration behavior, and he in his local machine would request voters public keys to generate circuit and make all other operations. To do it, he call voters contracts addresses, voters contracts functions get pk. It is the answer of voter contract of administrator copy this value and create file in our demonstration as such hard execution, but in production it would be made much easier. Administrator create file with this voter public key, and he do it for every voter. the second public key. Third key, and the last one. So he got all public keys of voters, and at the next step, he firstly run CLI with init-admin flag, and by this command, he will construct Merkle tree upon voters' public keys, generate session ID, generate circuit, generate CRS, which consists of proving and verification key of gross chestnut 16, sorry, and generates public, secret, and verification keys of Elgamal encryption scheme.
I have questions.
Mm-hmm.
The first question is, what this circuit does? So, what it is it for? Is it just a set membership check or something else?
Yes, it do membership check, and also it circuit built upon this relation, and this relation ensure desired properties of protocol, which make a relation between ballot and voter without identity disclosure, which also ensure that in every session
the ballot is unique.
Yeah.
Mm-hmm.
I noticed that CRS generates relatively long. So why does it take that much time?
There may be some optimizations problem in CLI, but it is in perspective should be fixed.
A fixed amount of time? Or, well, I'm asking because in your example you use only 4 public keys, and what time it will take if I say take 1,000 of voters? How much time and how much data should I produce for this CRS?
Yeah, and I would add to that. Actually, the whole point of this contest was to test whether it's possible to have not 1,000 but 1 million voters and more. At least from my perspective. So it would be very interesting to see and assess how it will work if there will be that number of voters.
The bottleneck here is generating CRS, and
it gets done only once, by the way.
Hmm?
It gets done only once, I mean, during the setup. And I also noticed that you've built this whole thing in debug mode, as far as I see. That's kind of 10 times difference.
Once for all elections or once for each election?
Once for each election.
No, CRS is generated once for one election. I'm sorry, for yes, for each election.
No, yeah, for the election session, yes.
Yeah. No, not for session, because session could be processed with the same CRS for each session. LGML keys should be generated.
Yeah. It depends on the uniqueness of the LGML keys. Yeah.
Could I continue?
One small question. What do we have as an output after this step? So do you have some kind of maybe some file was generated with some data? Could you please show it in the console?
This step were generated much files, but not all of them will be used by during the interaction with LCS, some just for testing purposes, which are crucial for protocol execution are RDNCS proving key is part of CRS. RDNCS verification key is RT, which is root of Merkle tree built upon voters' public keys is EID. It is session identification ID. Also, it is keys of LGML keys, public key, secret key, and verification key. So from this step, all files are needed. Sorry. So we generated this step, so we could run this command again. The files will be used by this script, and the first command is to deploy, to upload CRS.
By the way, about the reference string generation, we got a concern that you kind of missed to mention that the generation time doesn't depend on the amount of voters.
Sorry, can you please comment the command line you just put? Because I saw PK and VK is empty and PK is very small. Why you put those values?
Yes. There is some problem with PK because it, as you can see, verification key is 33 kilobytes and proving key is 4 megabytes, and to upload it by the manual copy paste is too hard. So in this, it is one thing which we will in some sense cheat because we copy this file manually between folders, because to upload it should take a very long time. VK, because too large output, too large command is not accepted by the FLD cluster. And VK, as you can see, is split into several parts.
Okay, I got it. So the next question, does the PK and VK size depend on the number of keys?
You mean number of voters?
Number of voters. Yes.
It depends with linearly, as the most of the circuit which generated is the most size of the circuit is taken by the internal internal wires, not publics, because there are much hashing. So it become increase from this value not to by big step. For example, if we run CLI for more participants, for example, for 16, then if I don't mistakes, will be equal to 11,000. So from this point, it will increase much more slowly, not by exponential or
okay, so it's sublinear. And
yeah.
but is it logarithmic, or because the question is, of course, what about big numbers? What about like 1 million plus?
It could be checked. By the way, I cannot exactly say, not exactly. I'm sorry, I forget word in English. I cannot make estimation at this moment.
But it feels that this file will be really big for 1 million voters. If for 4 voters you receive 1 megabyte of data, or how
be,
I don't remember. Well,
according to article, for example, they executed protocol, and their results was 16 megabytes CRS for 2 powered by 16 voters.
Yeah, that's fine. It depends how it will grow.
You gotta note that the CRS actually doesn't have to be uploaded the default tolerant cluster because it is being generated once and for everyone, and no one has to trust it because it is being generated by the administrator. So you can safely store it on some, I don't know, like CDN or like whatever. Just to avoid concerns about the size of the CRS, which is supposed to be uploaded to the fault tolerant cluster, well, you don't have to upload it to fault tolerant cluster actually.
But I guess, but how it will be tested and how you can test it? So it means how users can prove that it is correct CRS.
In case there are, I mean, in case there are, let's say, you know, doubts, they're free to regenerate that themselves. Well, it's just to cope with the size, all right? that's what it is for.
How long it will take?
The generation of CRS?
Yes.
I don't test it for larger numbers, so I cannot.
4 is pretty much a low better, so I think you should test on.
For example, in this setup, the setup phase was only 3 seconds, so there are possibilities to optimize current implementation, so it shouldn't be too long in production.
It doesn't grow so fast, according to the paper. I mean, the theoretical estimation.
Yeah, if they calculated it right. So.
I'd like to say that it looks like the circuit itself doesn't depend on the amount of the participants. In this case, it should not increase times or size of CRS from the increasing participants amount, because the goal of the circuit is to prove kind of one participant results, as I understand the protocol. So in this case, it's just doesn't change from the bigger numbers of the participants, of the voters.
Yeah, if algorithm doesn't depend on the number of participants, the checking algorithm, then probably you're right.
I can hardly imagine how the circuit does not depend on the number of voters if it does a membership check. So it somehow should include this information within itself, no?
It could be algorithm. No, circuit.
Can I say,
yeah.
the only part where the circuit grows with participant number increases is this path. This is path of the Merkle tree. So MRDNMN define ballot, EIDSN, RT are constant, and path is the path of the voter in Merkle tree. So you could say that circuit grows logarithmically. Yeah.
Yes, exactly. But by the way, there is a string says upload CRS on blockchain. So you should have to upload it.
This part.
No, if you see init system relation, upload CRS on blockchain.
Yeah, it what administrator does and what we are going to do.
Michael said that you can not upload it on blockchain because it can be generated independently. By the way, you cannot do it independently because you don't have access to public keys. Because public keys is
Yes,
provided,
you're right.
yeah, which provided to an
Mhm.
administrator. They, I mean, the administrator knows them, so that's why the administrator should not be able to make relation between voting and public keys, but it's not public information.
Yeah, it's like not every participant has the public key list. All right, yeah, you're right. I guess I should have thought about it.
But then it's a very good question how we can check that. Technically, I mean, we cannot check that CRS was generated correctly, but voters themselves can, if they, for example, provided public key and then they see that check shows that they are not voters, then that such situations could be recorded and reported. I'm just thinking from practical point of view how you can control, or I mean somehow control the administrator. But this is when you this is a question when you check that your public key was not included and you can show it. But what about what about proving that there were no additional public keys which were included into CRS? That's another very, very interesting question, by the way.
Agree.
Administrator generates relation using chosen public keys, and he when he uploads generated data, he with so he upload PK lists, which should be
so does it mean that administrator should make PK list public according to the algorithm? Because yeah, it looks like that
Might be public. I mean, it can be public. There is no harm in that.
Yes.
Okay.
These data which he upload to blockchain are public.
Yeah, well.
Okay, that makes sense, because then there could be some control from the society that at least number of public keys corresponds to number of voters, and then anybody will be able to check that CRS is correct, and keys, by the way, as well.
On the other hand, it's a huge amount of data, and maybe blockchain is not that good to store this. Huh?
I would say the only thing that matters in here is if you have to store this data as a byte blob, or it can be like transactional, if this data is atomic or it is transactional. If it is transactional, if it is per transactional, so there's no problem with that. Just put like a million transactions inside and you're good to go. In case this is atomic, like, I don't know, like a huge byte blob which should have been uploaded, well, then we got a problem. But the only byte blob we have in here is the CRS, which size is, well, pretty limited. It has its upper limit, let's say it like that.
I think that only reason to upload it on blockchain if some smart contract use it. If if not, if you can do, if it's used only for field ballot generation, then you can store it somewhere else with signature of administrator. So the question is whether this data is used by any smart contract on chain.
These data catalysts, for example, are used in other phases of the algorithm when
it could be used by on the client side, or it can be used by smart contracts. That's different. The main difference.
It's not used by the TVM logic. The implementation supposes for it only to be stored inside the TVM, and that's it. I mean, no logic depends on it. You can check that on voting admin file, like lines 28 and 34. It's actually just about storing it, nothing else. I guess that's why I thought it could have been uploaded to some CDN.
Yeah, that's fine in that case. Okay, and what data is used by smart contracts then? For verification and for adding votes.
Can you
I'm sorry. So you have this line 79 in voting admin file.
Yep.
So where you reference the voter's address value. So you use it in the logic.
Yeah, but it should be that's the address you reference, but it should be compared with some data. And the data should be on chain.
Sorry to interrupt. It's just to answer the question. Yeah, it's like the line 29 is just about resetting the
not
context.
29, 79.
Sorry. Apologizes.
This one,
Yes.
This logic is used to check that every participant, every voters commit the ballots by calling to commit ballot. So when this stage, when all voters will be committed and it will be set, its state will be set to true, administrator could start tally last phase of the protocol.
Sorry, but does it mean that all ballots are committed independently, or so it's just committed, or is there any calculation or change of the state of something on chain when commitment happens? A part of commitment itself.
Can you repeat, please? The question is how committing is happened.
Yeah, and does it used by some smart contract to change something, to change some homomorphic sum, encrypted sum of
No, smart contracts from the cryptography logic only check the ballot of voters when they upload them using update ballot function, and when voters are ready to commit, when they upload them, they can do it in several steps, because in current implementation, ballot could be large. So it's ballot checked, it saved in the smart contract, and
So when you say saved in the smart contract, do you mean each ballot saved separately? Is it correct?
Yes, each ballot saved in in specific voters contract.
And that address calculated, and you can check that address of that smart contract is correct. I mean, code of that smart contract is correct. So how the process? You deploy specific smart contracts first, and then put ballot in it.
The process that is that you deploy a smart contract, you set public key and admin address which hold session information, then voter upload ballot, then their voters commit ballots, after which check ballot function of administrator smart contract is called.
I see. So there are no any calculation until the voting end. So the only limitation is that you will not be able to commit smart contracts into that specific commit ballot into that specific smart contract if it's not correct. So
if ballot is incorrect and this protocol check growth verification is not verified, then ballots won't be committed. Yes, if I understand you correct.
And once it's committed, are there any messages coming to some other smart contract which like try to aggregate?
Aggregation happened locally by the every participant, admin and voters. To do this, admin and voters will call get CT function of every voters protocol to admin knows voters addresses because it was initialized with this information, but voters don't, but they have access to the admin get voters addresses function from which they could get addresses of other voters and get their ciphertext to aggregate it locally and verify voting results. It will be demonstrated in the presentation.
Okay, actually, I see that people start going out. Yeah, there's already spent 1 hour. What I propose, there was a document which we wrote for GBA, and Mikhail saw it, where some criteria for voting were established, like which includes, by the way, how you can audit the results of a vote by some other by the third party. Is it possible that you will use those criteria and will make some statements like nobody will be able to disclose the connection? Then from practical point of view, how much time setup will take for like million voters, and what will be the size of all system components for that? Then how like third party check that the whole setup was correct and the results which were announced correct. So
you mean metrics?
Statements like properties of the system.
Oh, okay. We'll measure them.
Yeah, measure that's one part, but also statements. How's better to say, security statements or property statements. Not only measures, but also that that's the way how third party can check that the tap was done correctly and calculation was done correctly.
Okay. Okay. I mean,
That's
just just a procedure description, I guess.
Yes, for audit or
Right.
audit description, and try to calculate how it will look like if we will decide to make it for 1 million people.
All right. All right.
I think you'll be able to summarize it in a couple of slides, and it would be very interesting if you present it on a community call as well.
Sure. Sure. All right. All right. Let's do it.
Okay, I will leave as well now. So
Okay.
if there are any questions from other participants, they're
Nope.
welcome.
I guess then we're done.
For now.
For today, yeah, for today.
It's a very complex thing, so it was quite optimistic to think that it was possible to present it in 1 hour.
Oh well. Anyway, we'll probably have the second round of this thing because, well, there is one more participant.
Yeah, hope so.
All right.
Great. Okay.